Okay, last video for Chapter 8, we're identifying special quadrilaterals. Our learning target is we're going to use all of the properties that we have and look at pictures or words and decide which quadrilateral it is as far as a parallelogram, a rhombus, a rectangle, or a square. So example 1 says quadrilateral ABCD has both pair of opposite sides congruent, and what type of quadrilaterals meet this condition? So if opposite sides are congruent. Okay, so that would be these pictures here. We have a possibility it could be a parallelogram, and we have a possibility it could be a rectangle. And if opposite sides are congruent, could it also be a rhombus or a square? Okay, what if we know that just the sides are completely congruent? So now, again, instead of having these two and these two be the same, now we have all four the same. So that means we can be a little more specific, and we know that both rhombuses and squares have to have all four sides the same. Okay, example 2, quadrilateral J, K, L, and M has both pair of opposite angles congruent. So if we just made ourselves a picture, we know that we would have opposite angles congruent, and we want to know which quadrilaterals meet this condition. Well, we know that opposite angles being congruent is a property of a parallelogram. We also know it's a property of a rectangle, a rhombus, and a square. Now, if we do not know anything else, we cannot be more specific. Okay, let's take a look at example 3. Now we're going to look at just the picture and decide the most specific name, and again, that's important. You're not picking all the names that it could be, you're picking just one name that it could be. So on this particular picture, we know that we have 4 congruent sides. Okay, so if we look at our properties, we know that from up above, we had even talked about it, if all the sides are congruent, we know it has to be a rhombus or a square. But in this case, we do not know anything about the right angles, so that means it could only be a rhombus. Okay, if we look at our other picture, we have 2 sets of consecutive, remember that means in a row, consecutive, congruent sides. So if we look at all of our shapes, including the kites and the trapezoids, we know that the last thing we learned on the kites were that 2 sets are congruent as long as they're side by side. So this would have to be a kite. Okay, let's take a look at example 4. Is there enough information given to show that this quadrilateral, again 4-sided figure, is an isosceles trapezoid? Okay, first of all, we have to prove it's a trapezoid. So if angle G and angle H are supplementary, need bigger spaces, or equal to 180 together, and they are, if we add up 102 and 78, it equals 180, then we know that it's parallelogram. But if it was a parallelogram, we would have to have opposite angles congruent, and opposite angles are not congruent. So since F and G are not the same, or F and H are not the same, again, because to be a parallelogram, these two would have to be the same. We know that this is parallel to that, so FG is parallel to JH, so we only have one set of parallel sides. So FJ is not parallel to GH, so that means it has to be a trapezoid because we have only one set of parallel sides. Okay, now we need to show that it's an isosceles. Okay, if we look at our picture, F and G are a pair of congruent base angles. Remember, this is the base that's parallel to this base, and if both angles touch the same base, they are base angles. So F and G are a pair of congruent base angles, and so FGHJ is an isosceles trapezoid. And again, I don't like numbers, so let's say we know that we have congruent base angles, and that's what makes it an isosceles trapezoid. Okay, this is a rather short section because we're really just going to decide what we have. So, second page, example 5. Is it enough information given to show that it's a rectangle? Okay, if we take a look at it, first of all, we know it has 4 sides, and that means it is the quadrilateral. And now we're going to take it further. So first of all, we have 4 sides minus 2 times 180. So the inside, or the sum of the interior angles, is going to be 360. And so we know that we have 3 angles of 90, so 360 minus 270. So we know that last angle is a 90 degree. So angle D is 90 degrees using the inside sum of the interior angles measured from section 1. Okay, we also, which means if we can put this here, we also know that opposite angles are congruent. Okay, that just makes it a parallelogram, so we need a little bit more. Okay, we have consecutive angles are supplementary or equal to 180. That again doesn't make it anything further. That's a parallelogram property. However, we do have 4 right angles. Okay, that with these other properties lets us decide it is a rectangle. Okay, like I said, this is a short section. We're just going to be looking at pictures and trying to decide if we know what they are. Thank you.